named middleware.ts. Okay, basically what's a middleware? It's what, like, whenever we make any request to the API or to the application, okay, it's what stands between us, between the request. Like, it goes through the middleware. So whatever you write on the middleware, like to check, for example, the request and everything, it's going to stand between the request and middleware, the requester and the middleware. So for more details, actually, we can go ahead and no, let me just go ahead and open Next.js documentation. I think that's much better, actually. Next.js documentation, and just open docs here, so we can understand how many minutes. 20 minutes. Okay, so I'm going to go ahead and type here the proxy. Let me type proxy here. Proxy dot something. Yeah, here. Starting with Next.js 16, middleware is now called proxy. Okay, and proxy allows you to run code before the request is completed. This is the idea. Then, based on the incoming request, you can modify the response by rewriting the redirection, modifying. Yeah. So, common scenarios where proxy is effective include modifying headers for all the pages and subsets, and redirecting based on convention. Yeah. So basically, here is where we put the CORS policy. Okay, security checks, CORS checks, and the rate limiting, if you have rate limiting, where you put the security headers, and yeah, authentication, also authorization. You can add it on the middleware instead of adding it on inside each API route, like going to each API route and writing all this configuration inside the API route. And every API route, if you have, let's say, assume you have more than one API route. Now we have posts, right? Let's say you have users, or again you have tasks or some other API routes, right? A lot of API routes. You can't go ahead and write it down on each API route, right? It's going to be redundant and time consuming also. Yeah, you can add all this in one component and import it on the API routes. Again, this is also possible, but proxy is much better. Adding it all in one file, in one file like this one, proxy.ts, is going to check before the request, before going to the API before the request is completed. Okay, it will apply for all. You don't have to add it on one by one on every single API route. That's the idea of proxy. Let's go ahead and try to understand the theory, and we will move on and write the code. So before writing a single line of code, it's essential to understand why each security mechanism exists. Section explains the concept, attack vectors, and mental models that make the lab code meaningful rather than magical. The same origin policy is a browser foundational security rule. It restricts how documents or script loaded from one origin can interact with the resources from another origin. What counts as the same origin? Okay, 3 things must match exactly: protocol, HTTP versus HTTPS, domains, and ports. Okay, so in order for us to call it same origin, protocol has to be the same, the domain has to be the same, the port has to be the same. Okay, so we can say that the request is coming from the same origin. Okay, this is implemented in the browsers, actually, same origin policies. It restricts how documents, scripts loaded from one origin can interact with the resource from another origin. And same origin checks, let's say we have this one from the front end, and we have this one on the back end. Okay, this is different subdomain, so it's blocked. Okay, and let's say we have here my app. This is because api.myapp.com, right? This is a different domain from this one. let's say this is our front end, myapp.com.443, but this one is not matching. This is so it's blocked. This is considered different subdomain, and this one also, this is different port. This is also considered subdomain. Why does same origin policy exists? Without same origin policy, any web page you visit would silently read your blank balance, send email from your account, exfiltrate private data from other tabs. Same origin policy forces strict to only read from their own origin unless the server explicitly grants permission via CORS. Okay, so CORS basically is cross-origin resource sharing. Okay, is controlled relaxation of same origin policy. Okay, so I think if you remember in our course on previous before 4 or 5 sessions, we talked about rate limiting. Okay, I mean, we talked about CORS, okay, with and merge stack. Okay, so yeah, so we had to specify so that React can talk to Express, right, on the backend, Express.js. So front end, in order for the front end to communicate with the backend, because they had different domains and different ports, actually, not domains, different ports, because so we were getting a CORS error. Okay, like this. Let me show you the CORS error here. CORS error. Let me show you the image here. This is a CORS error. Access to fetch from this from origin, this one has been blocked by CORS policy. No access control allow header present, request the resource. So because you see these are different ports, right? This 5000, this is 550, and this one can be also like this. Okay, it can be like this. Cross origin request blocked. Okay, the same origin policy disallows reading the remote from this one. Reason: CORS header access allowed missing, access control allow origin missing. So basically what we are going to do, we're going to add this header, access control allow origin, so that it can allow. Okay, that's the idea of CORS basically. So we can allow from different domains to communicate with each other. Okay. Yeah, it lets servers declare which external origins are allowed to read the response. It's entirely enforced in the browser. The server only sets header. Remember this one. So our job is only to set headers. This access control allow origin header. This one we have to set it in the middleware. We will specify which origins are allowed, and we'll set this one. Simple. We have 2 types of request in CORS. A request is classified as simple when all the following conditions are met. If the method is get, post, or head, headers are limited to accept language, content type. And content type is one of application WE form code. So this is basically a simple request. If we are using one of these methods, then it's considered a simple request. Okay, and like headers, for simple request, the browser sends the actual request immediately. Focus on this one because we're going to see why this is important. For simple request, the browser sends the actual request immediately and checks the response header. If the servers include the correct access control allow origin header. This is the one. This is the most important header that we need to see. Okay, the browser exposes the response to JavaScript. If the header is missing or wrong, the browser blocks the response. So our job is just to add this one, this header, to the request. That's it. So we have a simple request flow here. Okay, browser sends post API submit. Okay, no pre-flight. Okay, we'll talk about pre-flight after time. Just understand that when we use post, get, and head, we don't use, it's considered a simple request. That means we don't have any pre-flights. Server 200, okay, and access control allow origin. It checks this header. This is what's important. Browser checks header. If match, JS can read the response. That's it. So when we talk about pre-flight requests, okay, when a request uses a non-simple method like put, patch, or delete, or non-simple headers like authorization or X custom headers, the browser automatically sends the pre-flight options request before the real one. This asks the server for permission. If you understand this part, basically you know what's pre-flight request. So this is what we send before we send the actual request. Unlike simple requests, we just send the request directly, right? Because get, we're using method get is not harmful, right? Just fetching the data. Post is just adding the data. Okay, head same. So this is okay. We don't need permission from the server to perform any of these actions. Okay, but when we want to do edit, like use put or patch or delete, these are very critical actions. We have to, and authorization also, we have to ask the server for permission. How we ask the server for permission? We just send the pre-flight request before the actual request. Pre-flight request is like this. We have, for example, we use options actually. We don't use any other method. We just use options here. Pre-flight doesn't have any. We just use option here. Options API.users. And we give it the origin here. This is the origin. And we check access control request method delete. Okay. And access control request header authorization. Okay. So this is what we will send. Okay. And then what the server will send us is something called 204 no status, no content, sorry. No content. Okay, response. And it's going to give us this one, access control allow origin, this one. It's okay, allow this application, this domain. Access allow method, he's allowed to do get, post, patch, delete. It's okay. And access control allow header, content type, authorization. If you get this response, that means it's okay. Then we will send the actual request. This is a delete API user 42. Now you are allowed to delete. That's the idea of pre-flight. Okay, so common CORS mistakes using this asterisk with credentials. Okay, asterisk means all, allow all. Browsers reject this combination. Okay, forgetting the options handler. Options handler is important. Like here, we use options before the API route, right? And pre-flight gets 404. You get 404 instead of 204. We want 204. 204 means good, no content, right? It's allowed. And setting CORS header only on success routes. Errors still need CORS header, or the browser hides the error message. Yeah. So right now, what we need to do is, before moving on to the next topic, which is rate limiting, now that we know that we understand what is CORS, so I think we should try to implement it in our applications here. Okay. To do this, I'm going to go to proxy here, and I'm going to go to Next.js actually. Next.js application here. I'm going to type the documentation. I'm just going to type CORS here. Right, CORS here. Yeah. So this is CORS. You can set CORS headers in proxy to allow cross-origin requests, including simple and pre-flighted requests. Okay. So Next.js recommends to follow this pattern. So we're just going to follow Next.js recommendation, right? So first thing we need to do is just open this one here, and yeah, I don't really need that one. One second, let me just close this one. I don't think there's an option to just close this one, so leave it. This is the CORS. Okay, and expand it a little bit and put the code here, and remove this one, put it here, and also we don't need this one actually, so remove this one as well. And yeah, so what we are going to do, we're going to set CORS based on XJS recommendation. So first we have to import, let's go ahead and import next request. In fact, let me just copy this one because we don't actually need to. We just import this one. Okay, and so next is actually we have to specify the allowed origin. We'll follow this pattern. Okay, or let me copy the entire pattern here, the entire pattern here, and paste it here. Okay, we're going to modify it as needed. So this is the allowed origin. Here we specify what we want to allow, which external domains we want to allow. Okay, let's say you're using a different backend for your application. Okay, you have to put it, you're using Express or some other backend technology like Java or Spring Boot or some other. You have to specify the domain here because in order for it to communicate. So right now my domain is actually this one, so there's nothing else we need to do here. I'm saying allow this one, allow this domain. Okay, it's going to be different if when you in production environment, like you have a real domain, right? You have to specify it here. These are the options. Okay, CORS options. I'm just saying these are the options. This access control allow methods. Okay, allow this methods, basically access control allow headers, content type, and authorization with the CORS options. Okay, and then we have export function proxy. This is basically just I'm just defining the proxy function, this one, request, so we can get the request, any request sent, we can catch it here. And we have here this one, we can const origin request headers dot get origin. So we're just going to get the origin header from the request. Okay, we're going to get the origin header from the request. Okay, we have here the origin. Okay, but before this I want to see exactly, this is the origin header. Okay, check the origin from the request, and I'm going to show you where it is actually. I think we should do it actually. Let me just open let me just write front end so we can test it. Let me just type here. I'm going to write a simple CRUD application page.tsx and import React from React, and I'm going to say export default posts, return yes. So basically I want to write the application. Okay, so I'm just going to go ahead and type this is it, and so this is for fetch. This is great, and so now here we can just add here, yes, it's much better, and so property ID doesn't exist, and this is also, I think we should have a button to edit and stuff. I should have a button here to not to fetch, to edit, to okay, fine, because yeah, we can do that as well. We can put it inside an anonymous function. That's fine, because again, the goal is actually not to write a CRUD application. Okay, it's just going to be to so edit button here. This is for edit. Yeah, for the patch, and just to demonstrate our focus is on security. So I'm just going to make sure to write any working code that it will be enough here. Okay, so yeah, and yeah, we have this one. So I think the issue now is because we are using TypeScript, we have to actually use the type here to find the type post, and title, description, and that's great. So here I think we should add the post here. I think it should be added, yeah, which will reduce the errors. And now that ID is actually there, what else we have? Maybe it's never okay, let me never any property ID does not exist on type never. Okay, let me just go ahead and just okay, I think we should have something here saying that, so it can be, yeah, can allow post no, it should be not null here. So I think it's done. The issues is fixed. And let's see if it's actually going to work or no. Our CRUD application. Let us test it. And I'm just going to say post here. Proxy missing expected export name. Okay, that's fine. I just need to save this one actually. Use state, okay, so we have to add use client actually in the page here. We should add use client up. Yes, use client, save it, and yeah, so we just got also I think we need to have add also, right? But it doesn't really matter. Important for us is get and delete, update, because those two are going to generate a pre-flight request, right? We want to see how the pre-flight request is actually reflected. Get is enough here. So post is just not going to generate any pre-flight request because it's a simple request, right? So now that we have this simple code, okay, I'm going to use burp suite. Let me download burp suite here just to inspect the headers here. Burp suite community edition. Okay, this is actually a tool that's used by bug bounty hunter or cybersecurity professionals in order to inspect the headers, a request and response. Yeah, the community header. Yeah, this is actually going to take time, so I think we should pause the video and take a break and come back again. So I just installed Burp Suite. So just so we know what's Burp Suite. Burp Suite is just a way so you can intercept the requests. Okay, whenever you refresh here, you're going to see all the requests here. Like here we have the get request, get method here, the post, whatever you make here, it's going to see it here. Okay, so now that we made, if you notice here, now that I refreshing this one, when I refresh, it's going to make a simple request, right? No pre-flight requests, because I'm just fetching. I'm using get here. Okay, even when I use post, which you don't have here, but if we use post here, it's going to be same, right? Just one request here. This is the request, that's it. Okay, and assume that now what we need to do actually is going to be, yeah, we're going to try to first delete this. We're going to use delete here and see what happens. Okay, actually I just deleted it. If you go here, we have delete here, and yeah, wait, got the delete here. Okay, and we have the access control allow method get post. Okay, and we have the content type authorization, which we set from the on the API. Okay, and we have this because it's coming from the allowed origin. You see this one, because it's coming from the allowed origin. Okay, you go here, inspect, go ahead, go to the network. Okay, it allowed us we have the allow method, allow origin. But let's say we just even without proxy, we're going to be able to do that. But since we are already inside the okay, yeah, so these are the headers that we are setting right now. Access control allow header here, content type authorization. Okay, and these are the allowed headers. Okay, whenever we make send here, or yeah, we can actually see the headers here, origin here, that we are setting. Okay, let's do the same thing, but we are going to remove this one. We're not going to use this method, not going to have anything actually. I'm going to take the proxy itself outside. I'm going to put it in public for now. So now we don't have any proxy. Okay, see what happens. If we don't have any proxy, this is what's going to happen. Whenever we want to delete, okay, let's go ahead and delete now. I'm going to delete this second one. Okay, I just deleted it. You can see the post here. See, there is no header here. You see this? This is the difference. Okay, there is no allow header. And let me send this to repeater. Send the previous one also to repeater. Okay, so we can compare the both requests. Okay. Yeah. So you see, this is the one that we had on the. No. We want to compare the response actually, not the request. So I think better, yeah, this is the previous request, and No, right now because we removed it, it's not going to show, but we can see from here. Okay, so if you can see the response here on our previous when we deleted the item, the post, it added 3 headers here. Allow header, just to allow content type and authorization, and the allowed methods here, and the allow origin, because we specified on the proxy, right? But if you the next time we did this, next time we deleted another item, when we removed without the proxy, there is no header here. Just deleted it without header. And the reason we didn't get any CORS error is because actually we are using Next.js actually, so it's going to use the same domain, so we're not going to get any errors here. But if you were using Merstack, you're going to get an error. So that's the idea. So we're just adding these headers. Okay, the purpose of CORS is actually just for securing your application, like to prevent attackers, also to the purpose of same origin policy. CORS is just to relax this one. So what we need to understand here is, like, we just added these headers as you saw. Okay, and first what it did is it got the origin header from the request. Okay, so we can know from where this request is actually originated. And this one, let me show you where is the origin header actually. This one, this is the origin header. Okay, so we're just getting this one, so we can see where the request is originated, and it's going to check is allowed origin. It's going to create a variable and check if allowed origin dot includes origin. It's going to check if the origin that we got from the request matches this one, the allowed origin that we specify here. Okay, and then it's going to handle the pre-flight request. Since we are going to perform a delete or update action, it has to check the pre-flight method, right? Is pre-flight equals to request method equals to options. It's going to check if request dot method, if the method is options. Okay, then it means it's pre-flight, right? So if it's pre-flight, then what you are going to do, you're going to check if the allowed origin, if is allowed origin here exists. Only if it exists. This is spread operator actually. It's just saying if this exists, if is allowed origin exists, then add this origin, add this one. If it's true, only if this is true. Okay, then add this header, access control allow origin. That's it. That's the purpose of this code. Okay, this is this one. It's adding this one. This is what we mean here. Yeah, this one. We just added this one. Okay, and then we added also CORS options, the two additional headers here, allow method and allow headers. We added this too. Okay, and then return this next response to JSON headers, pre-flight headers. So that's it. That's the only thing we did. And to handle simple requests, okay, const response equals to next response dot next. If is allowed origin, response header dot set. This is it. Just set the access control allow origin to this one. That's it. Just set this header simply like that. Yeah. So that's what we mean by simple requests. And also add this one, object.interest CORS options. This is just to loop through the headers that we mentioned inside CORS options, and set it like this key value based on there, and return response. So that's it. Basically, we're just adding headers to the Same thing happens when we do update here. Okay, whenever we make any updates here, it's going to do the same thing actually. Just going to go ahead and do this. Okay, and it's going to do that. One second, we can go ahead and go back here, and yeah. So it's going to do this one. Yeah, so this is basically the course. I think this is enough for course. So now we can move on, because it's been already, we hope this is clear. That's the idea of course. And the next topic is going to be course origin. But before, the next topic is going to be rate limiting actually. Before moving on to the next topic, I think we should take a little break and we'll move on. Okay, now that we finished course, it's time to get into rate limiting. Okay, so what's rate limiting? Rate limiting caps how many requests a client can make in a time window. Okay, without it, a single IP can flood your API, exhaust your database connections, run up cloud bills, and brute force logins, credentials as well. So this is the idea of rate limiting. So basically, let's say some basically what it means is, like, let's say there's an attacker or want to do something like wants to flood your API. Okay, basically I can just send get request here again and again and again and again, like until we'll have too much requests that your server will be down, or there will be issues with your exhaust database connection and stuff, right? There is no way to control me from doing this. There is nothing to stop me. Okay, I can just refresh, like, the post, the get method application, and refresh it 100 times, or send you multiple thousands of requests, okay, to your API or to your application, right? There's nothing stopping me from doing this. Okay, and then this could cause issues in your database, or also increase, if there is a limit on your API or something, like bills. It could increase your bills, your stuff, and also you can brute force the credentials. So in order to avoid this, okay, we have to set rate limiting. Like, for example, rate limiting means basically I'm going to say, after in this 60 seconds, for example, window, okay, I'm allowed to make only, like, let's say 10 requests. Okay, more than this, it's going to prevent me and give me an error. Okay, too many requests, error 429. That's the error code that we use. And so basically that's rate limiting. Okay, sliding window. There are several rate limiting algorithms. Okay, we have Upstash uses a sliding window algorithm, which is the most accurate for real world traffic. Yeah, the most used is actually this algorithm. We call it sliding window. Okay, we have three algorithms: fixed window, sliding window, and token bucket. Okay, fixed window, how it works, count resets at fixed intervals. Okay, for example, let's say I set let's say I allow burst at a boundary, 60 requests in the last second of a minute, more in the first second of a minute, equals to 120 a minute to. So this is the idea. Okay, so let's say I set only a fixed window, let's say 60 seconds. Okay, 60 requests, or 60 seconds. So after the 60 seconds, yeah, it's going to reset the counter. Okay, so you can yeah, so what issues it has is, like, it bursts at the boundary. What it means is, let's say before this 1 minute, okay, finishes, at the end of this minute, okay, I just sent 60 requests in the last second of the minute, okay, and 60 more requests in the first seconds of the minute of the second minute, okay. So it will be 120 in 2 seconds if you count it. See, yeah, that means I will send 120 requests in 2 seconds. Still, this is too much, right? So this is the issue of fixed windows, because basically it will the problem is, like, because you have only a fixed window, okay, let's say 60 seconds, okay, you said that you put a rate limit for 60 seconds, okay, and after 60 seconds it's going to reset automatically the counter. So now you can request, like, so what the issues it causes is burst at the boundaries, okay, but actually this is not what we are going to use. The most used algorithm is actually sliding window, okay, and token bucket is actually tokens refill at fixed rate. Each request consumes a token, okay, slightly more complex, great for burst tolerance. Yeah, token refills at fixed rate. Okay, you can read about it. You can read about token bucket and fixed interval at the same on your own time, like by yourselves. But the most important thing that we need to focus on is the sliding window, because this is the most used one and the one that we are going to implement. Okay, so how it works is the count is weighted over a rolling window of the past n seconds. Okay, no boundary bursts, always accurate. Okay, yeah, count is weighted over a rolling windows of the past n seconds. Okay, so sliding window uses there is a window, it has a window, let's say 60 seconds, but it's not fixed. Okay, you can move on, like for example it can we have this issue with the burst, right, in the last seconds of the first minute and the first seconds of the second minute. Here it's going to slide through it. We don't have a fixed window, it's going to slide through it. This is a sliding window. Again, you can read about it on what to limit. You can limit by IP address, the most common, easy to implement, can be spoofed but still effective against casual abuse. Okay, and you can limit by user ID, better for authenticated API, not affected by IP rotation. API key, ideal for third-party developers, but we are going to use IP actually. Okay, I want to try rate limit using the sliding window first, and then we're going to move on to security headers, which is the last actually topic. So let me just try to do it here. Okay, now that we have this one, first as usual it's better to always refer to documentation, because things might change, like the syntax, and maybe there are new ways of doing things. Like this is Next.js documentation. I'm just going to go here, rate limiting. So you can implement rate limiting in your Next.js backend, in addition CORS-based checks using this one. Okay, yeah, but actually, yeah, this one, lib.rate limit. No, for this one actually I prefer to use upstash rate limit. This one, upstash rate limit. Okay, this is the documentation. Yeah, so it's the only connectionless HTTP based rate limiting library designed for serverless functions, Cloudflare, Next.js, and all that stuff. So what we will do is like handle blocked requests without having to call your Redis database, timeout and stuff, multiple limits. So I'm just going to go to get started here. First thing what we need to do for the rate limit to work, we need to create upstash Redis and get its credentials. To create an upstash Redis, you can follow this one. Okay, so okay, I know how to. So basically what we need to do is first thing is we need to install this one, upstash rate limit. Copy this command, okay, npm install cmd. I'm just going to go to the folder here and I'm going to install this one, okay, and until it finishes we're going to go ahead and we have to actually create Redis first. We can go to getting started here, create upstash Redis. I think we created this one in the previous when we talked about caching. So what we need to do basically is just get the keys. There are keys here we need to take. Let me log into my Redis here. Let me just go here, upstash Redis here. I'm going to log in here and I'm going to continue with Google here. I'm going to log in. So I'm not going to create a database because already I have one, but you can create it, but it's going to ask you to pay. You're allowed to create one database, so I'm going to use my existing Redis database here, okay. And here I have an option here I just need to copy this one. These are the API key, the keys. Just copy this one and put it inside .env here, okay. And also I think we need to add something for the this is for Redis. And now that we have for rate limit, and that's it, okay. Next step is to add rate limit to your endpoint. In this example below you can see how to initialize rate limit and use it. So what we can do is like follow this command, okay. This they have mentioned here, but I'm going to do it in my own way. 1 second. I'm going to go ahead to my Next.js application and I'm going to go to my proxy, okay. I'm going to import Redis and the rate limit here from upstash rate limit on the top, okay. This is fine. And then I'm going to create a new rate limiter that allows 10 requests per 10 seconds. This can be modified as needed, okay. Let me copy this one, okay. Just understand the syntax. The syntax is the same actually. We can just go ahead here below the this is the rate limit. I just defined the variable rate limit, and this is this one I imported from upstash rate limit here, and it takes the Redis, which is Redis from MV. This one we got from Redis actually, okay. From MV we just creates a new instance, upstash Redis instance from the environment variable. Basically it tries to load the connection details from your environment variable using process.env. This is the same as saying this one. You see, if I can just write process.env upstash Redis rest URL and token. So this is just taking the this two, and here actually it's saying the token is actually hidden. I don't know why. Let's 1 second. Let me go back here, open it here and just copy this one and paste it here, okay. Now let me go back to proxy, okay, and go back to here. And this one is just optional. And limiter, this is important. This limiter, what we mean by limiter is like we have to define which algorithm we are going to use. Sliding window here, so here I'm saying rate limit dot sliding window, and I mentioned here 10 seconds per 10 requests per 10 seconds. This is what's allowed, okay. But I think yeah, let's do it like this for test practice. And analytics and prefix, this two are optional actually. You can keep it and take it if you need. Then we have to define the identifier. In our case, the identifier is the IP, right? We said we are going to do that based on the IP. So what we need to do is inside the proxy here, inside the function, I'm just going to say const identifier, okay, equals to, yeah, request dot IP equals to unknown. Okay, but yeah, equals to unknown. Okay, and then I'm going to do const success equals to await rate limit dot limit identifier. So we're just going to check. We're going to call this this one rate limit and dot limit. This is the identifier that we're going to use, the IP. Based on that, the structure success. If it's not successful, so just return too many requests status 429. That's it. 429 is the status code for request for rate limiting. Okay, and only allowed in within, yeah, again, you cannot use await without async. You have to use async. And here it's giving me an error. Okay, IP request does not exist on type next request. Okay, let me just see what is the here. And yeah, so next request. So the issue here is actually here, property does not exist on type. This is a TypeScript issue actually. Yeah, property IP does not exist on type next request. Let me go ahead to Next.js documentation, see how it is done properly here. Next.js, just type rate limit here, rate limit, rate limiting. Yeah, okay, the request. No, this is, he is implementing it on the, here they are implementing it on the API. But one second, I think it's, wait 1 second, let me type rate limit. Maybe I can find other documentation here. Yeah, I don't see anything here. So this issue, property doesn't exist on type next request, is I want to try something actually. Request.ip, this is because the IP is, 1 second, let me try something here. I can use the X4order header. Let me try the X4order header. There's a header called X4order header. X4order 4 header. Okay, let me just check here to implement API routes here. It's GitHub. We can see how they have implemented the So what I need to do is just find a way so I can get the ID, extract the ID from the request. Okay, if you go to our here our find a way to get the ID here. Okay, I think there is a better way. From the request we can get it from the request. The request that I'm making, the IP 1 second. How can I get the IP 1 second? The IP address of the requests is the localhost IP, window header, user agent here, and yeah. 1 second. Let me just go ahead and check this rate limiting in Next.js, because I think there's a different way. It's implemented in Next.js different way. Next.js rate limiting in, yeah, this is from Redis, and yeah, let's try this one. And Next.js add the rate limiting API. Proxy, actually we want to add it on the proxy.ts. But let's check first this one. To create rate limit inside Upstash, there's a blog here. You can use the code which we already did. Okay, they're implementing fixed window, that's fine. Identifier equals to API. Use your user ID, API key, or IP address for individual limits. We need IP address actually. Okay. Get client IP request. Possible, use your user ID or IP address identifier to limit usage per use. Let's see what's get client IP. Might be a built-in function or something. Let's see. For smoother, yeah. Let's go ahead and try this one. Let me check if it's a built-in function. Get client ID. Let me see if we can actually remove this one for a minute. Cannot find the name. Okay. I think we need to find a way to extract the IP address from the request. Okay, so let's see here, server actions, how it is done. Yeah, we did this one. We did this one as well. Get IP, but need to rate limit anonymous users, public whitelist. Liable identifiers IP address. In standard API direct access the request object, you can extract the IP from the request headers, but small helper, it looks like X forwarded for header. So yeah, this one we can use something like this. Okay, but yeah, this is X forwarded. Yeah, so let me just go ahead and use this one. Okay, I can just use this one. Try to use this one. Get the X forwarded by header. This is the header, X forwarded -4 request.headers get X forwarded .4. Okay, I'm just going to add this one, remove this one, paste this one. Okay, and yeah, put this one, remove request IP. So basically I'm saying extract the IP from the request, make it identifier, here the spelling, and yeah, identifier. So put it here, and that's it. Basically this is the code actually for rate limiting. That's all we need to do, and our job is done here. We can save this one and try. For all the requests I'm making this rate limit just so to check. Let me check if it is actually running. No, it's not running actually. I think it stopped. It's okay. Let me just No, it's not running, right? Yeah, npm run dev. So let's try this one. Remove this one, we don't need to do that one. Cancel this one, fetch it. I'm using the right API and everything, but something is not right, it's not working. Cancel this request. Let's try it on the Google here. Let me just put here the request, see what happens. Again, nothing seems to work. The rate limiting, maybe okay, maybe it's too short, but let's check the errors we're receiving. Maybe the time that I defined here. No, but the request also is not showing here, so there must be an issue. Yeah, it's not working properly actually. Now it's working. 1 second. Get API. So let me see here. Here we got connection refused. SL prefers. We should be able to see the. No, we got connection refused here. Let me just refresh this one. Restart it again to see if it's going to work or no. Let me open this one, copy this one, and open a new request. Just yeah, let's make a new HTTP request. Okay, let me paste this one. Next. I got an error, which is actually, yeah, the error that I got is actually because I'm using patch. Is that it? Yeah, I changed the request method, so it's working now. So let me try to do it again and again. 2, 3, 4, 5, 6, 7, 8, 9. Still 200, okay, 200, okay, 200, okay, 200, okay. I should be getting an error, actually, 429 error, but I'm not. That means something's not right on my, I said 10 seconds, 10 requests per 10 seconds, so I made like, maybe more. So, I think it has to do with the header, or Next.js actually, I think the way to do this is a little bit different, but we can check. 1 second, let me check, go through my notes here. We can go ahead and do the rate limiting. I think it has to do with the upstash Redis, because before I think I did it without using upstash Redis. It worked fine for me. So yeah, I think this has to do with the upstash rate limiting. Let me check it here. I think this rate limit is not working properly. See examples here. We have here rate limit on Versal H. Let me go ahead and no, I don't think we need to do that. Let me try this one. No. Yeah. 1 second. Let me check it. Yeah, so we can continue actually. Regarding the rate limiting, we shouldn't bother about testing it, because you can't test it actually. It's not going to work for you in the local development. It only works when you try to do it inside in production, because in local development, this is what happened on dev. This is what's happening actually. You're getting the IP, okay, from the first of all, X4 is only available on local environment. So by default, it's defaulting to anonymous, so it's treating all requests the same. So it won't work on. We cannot test it in dev. In order to test it, we have to just understand the concept, okay? And this is how we implement rate limiting. Let's continue with the next topic. I'm going to go ahead and do security headers. Security headers are HTTP response headers that instruct the browser to enable or restrict certain behaviors. They are one of the cheapest security wins available. A few lines of code protect against entire class of attacks. X-frame options prevents your page from being so these are the security headers. Just response headers. Okay, it instructs the browser to enable or restrict certain behaviors. That's what it does. We need to focus on this one. So this is what it does. Okay, instructs the browser to enable or restrict certain behaviors. They are one of the cheapest security wins available. A few lines of code protects the entire class of attacks. For example, X-frame options, this is mandatory, you have to add it, prevents your page from being embedded inside iframe on another site. Without this header, an attacker can overlay an invisible iframe over a legitimate button like clickjacking to trick users into performing unintended actions. Okay, so you should use this header, X-frame options deny. Okay, so basically clickjacking, we want to read more about clickjacking. It's just you can go here, so click jacking, you can go here, so see what it is. Yeah, like this. They can hide something here on the button. Okay, you will click it. When you click it, it's going to do something on the background. Okay, like this. Attacker places the malicious link claiming the attractive deal here, and in reality the click sends money to the attacker. Okay, the user clicks the visually harmless link to get clickjacked. You click the button and it does perform an action in the background. To prevent this kind of attacks, we have to add this header, X-frame option deny. Okay, and the next one is X content type option, stops browser from MIME sniffing a response. If a server sends a file as a text plain but the content looks like JavaScript, some browser would execute it anyways. Okay, setting no sniff prevents this. Okay, we can use X content type options, no sniff. This is also mandatory. We have to add it. You can read more about that also. We can go here and go to MIME sniffing. So basically MIME sniffing is just yeah. So you see this one, a sniff asset determine the MIME type. This is the browser. It sniffs the asset to determine the MIME type. Based on the content, MIME type equals to HTML. So this is MIME sniffing. Basically, it's how the browser behave, right? It's like it sniffs the type to find out the type of the asset. Okay, and yeah, to find out the type of the asset. Like even if the file type, even if if it sends a file as a text plain, the server sends text plain, but the content looks like JavaScript, some browser would execute it anyways. setting no sniff prevents this. You should do this one. XSS protection enables legacy XSS filters built into all browsers. Modern browsers have deprecated in favor of CSP, but it's still worth setting for compatibility with older clients. Okay, actually this is not, you can set this one X protection 1 mode block. Okay, but yeah, but it's not really mandatory now, I think, because there are better ways of protection against protecting yourself against XSS. It's called content security policy. And we have strict transport security, HSTS. This tells the browser to only connect to your site over HTTPS, even if the user types like this, HTTP, without putting S. Once the browser has seen this header, it will automatically upgrade all requests to HTTPS for duration of max age. You got me? So it's going to check. So this is the max age for 2 years, for example. Include subdomain, covers all subdomains, preload, submit to your site, HTTPS. So that's the idea. It's just converts HTTP to HTTPS. Make sure it's run. So we have to actually run this one. Strict transport security. Make the max age here. You can put it 2 years here like this. Include subdomains, preload. That means covers all subdomains. Okay. Submits your site to browser, preload. Let's HTTPS even on first visit. That's the benefit of this one. Preload. So make sure to set this one. And the referrer policy controls how much URL information is included in the referrer header when user navigates away from your site. Okay, leaking full URLs can expose sensitive path parameters or query strings. Okay, that's why you should use strict origin when cross origin sends only the origin, no path or query for cross origin requests, and the full URL for the same origin requests. This is recommended default. Okay, we have to set this one. Yeah, we should not expose the entire URL. Okay, and we have one more thing about this one. Yeah, we have to set the referrer policy also. And content security policy, CSP's most powerful browser security mechanism available. It lets you define a whitelist of trusted sources for every type of resources your page may load. The browser blocks anything not on the list, including injected malicious script. So you're telling the browser, okay, to whitelist the sources, okay, for every type of resource your page may load. Okay, the browser blocks anything not in the list. You're specifying what you need to, what you are allowed to load. This is very important and powerful. Actually, CSP is useful. We should include it on every application. This is the attack. CSP prevents XSS. XSS attack is very occurs when attacker injects JavaScript into your page, right? So common vector include, you can go through my previous course Red Team, and I've talked about XSS actually in detail. We have two different types of XSS attack, like DOM, reflected, and we have also other attacks. Like, let me show you what we mean by this one. I think we can demonstrate this attack here, XSS practice here. We can just check. No, let me try some vulnerable sites here. Any site actually, it's going to work whether in any site. Or let me just try this. No, that one is not there actually. Yeah, we can try this one, yeah. Or we can try this one, whichever you prefer. We can just to show you, I'm going to demonstrate what's XSS attack and why we should, yeah. Bugs, one of the most common dangerous types of vulnerabilities, blah blah blah. Let me add them. Let me type here the query. Yeah, So let's say I type, we have an input field here, right? Right, this is the search input field. Let's say I want to inject a script here. This is a script tag. We use it when we want to write JavaScript code. This is alert. You have been or just hacked here, and alert just opens a pop-up. Okay, it's just a normal JavaScript code. Okay, the thing is, this code shouldn't, the application shouldn't actually run this, okay, at all. But in our case, you see this one, it's run it. Okay, this is a simplified version, but an attacker could actually inject things inside more advanced scripts, run more advanced scripts, and application would run it if it's not using proper input validation or sanitization, like for these filters like script and other filters. It's going to be attacked by JavaScript. Okay, so CSP is a security mechanism, lets you whitelist a trusted source on every type of resource you may load, your browser may load. So we have here different CSP directives. Okay, we have default source. This is a fallback for all resource type not explicitly listed. Okay, and script source, JavaScript file or inline source. So in order to go to it one by one, okay, I think it's better if we go to another website called security headers.com, or well, let me just type security headers here. Yeah, I'm just okay. For some reason it's not opening actually. I needed this one actually. It's very useful header. Let me do one thing. You can copy this one, try it on a different web browser, maybe it will open. Okay, you've been blocked. Let me remove S here. Okay, it's blocking me for some reason. I don't know why it's blocking me, but it's blocking me. Let me open VPN. Let me try to turn on VPN here and see what happens. Yeah. Your VPN is on, so maybe it will work if we enable VPN. Yeah. The VPN is on, but it's not connected anymore. 1 second. Let me turn this on. Go to privacy. Yeah, it's on actually, but it's not working for some reason. 1 second. Yeah, so now let's go ahead and try this one. Yeah, so it's opening now. So actually this is not the site that we were looking for. Let me go ahead homes and see. This is not the site that I was looking for actually. I was looking for there is one site that's going to show you all the security headers. It has everything you need to check. Let's see here. Yeah, this one, this is the one that we need actually. We can turn on off the VPN now, we don't need it. But this HTTP security header, yeah, this X-frame option I told you, the ones it's recommended to use CSP, frame ancestor directive if possible. Do not allow displaying of page in iframe like this. XSS protection, the HTTP XSS protection response header is a feature of Internet Safari, stops the page from loading. Even though this header can protect users of older web browsers that do not yet support, some browsers don't support CSP. In some cases this header can create excess vulnerability in otherwise safe website source. So use CSP that disables the use of inline JavaScript. So if you use CSP, actually this vulnerability is not going to happen, I think. Okay, this is much better. So leave this one. Next, content type options. Yeah, this type no sniff. Referrer policy, make sure the referrer policy is only sends the origin. When we are cross origin, we just sends the origin path. Okay, the content type, yeah, set cookie. HTTP response header is used to send cookie from the server to the user. Okay, to send multiple cookies, multiple set cookie headers. So basically, remember we talked about authentication. We said that there are two types of authentication methods. We can use session-based or JWT, right? During session-based, we said that when you log in through any with the username and password through any authentication framework or whatever, you're going to receive an ID here, right? If you go in the application cookies here, you're going to receive here the session ID. Okay, so the session ID, the cookie inside the browser, right? So basically the server is going to send you the session ID. It's going to do that using this header, set cookie. HTTP, HTTPS, this is just we talked about it to convert HTTP to HTTPS. CSP, this is where we are now. Yeah, so the complex configuration, yeah. So we can add this one in CSP. Let me just copy this one, actually, CSP separately, and basically others are not really very critical. This is CSP. To the increase in XSS, clickjacking, cross-site leak vulnerabilities demand a more defense in-depth security approach. Defense against XSS, CSP defend against XSS in the following way. It restricts inline scripts. This is the main thing. And preventing a page from executing inline scripts, attacks like injecting, like this one for example, okay, will not work. Okay, you cannot just run anything inside the script now if you use this CSP. Restricting remote script, preventing page from loading scripts from arbitrary services, like this one for example. Script source, you cannot do this if you restrict the remote script. Restrict unsafe JavaScript, like this one for example, eval. Restricting form submission, restricting objects. So basically for CSP we're just going to add this one, things that we need to know for CSP is actually we have special directives here. If we put no URL match self refers to the origin site. Let me go ahead here. Strict CSP here we have here. Strict CSP structure, nuance based. Yeah, let me just go ahead and try this one. Okay, this is the default source, this is the script. It's important. Usually I think we keep it self or none I think. Image source, this is from where the image you want to source. This is the connect source frame and CSP values. Okay, we can actually try it in our code. Let's go ahead and try this one. Let's see how much time we have. Yeah, we have time. It's okay. Let's just go ahead and open Next.js here. Next.js docs actually. Docs. Let's type here the CSP. No, it's actually CSP. Is how to set CSP in your Next.js application. It's important guard. Okay, so we have an example here, strict CSP. And we can add nuance in proxy. Proxy enables you to add headers to generate nuance before the page renders. Every time the page is viewed, fresh nuance should be generated. This means you must use dynamic rendering to add nuance. In development, unsafe fonts is required because React uses eval to provide enhanced debugging. Yeah, remember this one. But remember to add this in development, when testing in development, and remove it in production. Unsafe eval. And CSP can block both inline and external script. Yeah. Nuance is a unique random string of character created for one-time use. It's used to conjunction with the CSP to selectively allow certain inline script styles to execute by passing strict CSP directives. Okay, so let's go ahead and start this one. Okay, so here we have okay, so let's just set a basic CSP here for now. We have here, this is a CSP header. Okay, so here default source, we put self. Okay, means the originating domain. Here also, yeah, here this is actually a good practice. You see what they did here? Unsafe inline. Okay, if is dev. Okay, if is dev, if it's in development, add this one, unsafe eval, in the script source. But if it is not in development, just put it empty, script source. Okay, and style source, like you can do the same thing here, and do this as well. So basically this is CSP. Okay, and you can just add it like this one, or just use this one here from the top. Yeah, we can just add it this one, like this one. We can just add this one, add it this way. Yeah, nuance will regenerate every time, every request. And we add this one here. Okay, I want to try this one. This is strict, so it's useful. Strict dynamic and image source. Yeah, replaces new line characters and spaces. This is okay. So we just have to put this one like this actually, and let me copy this one and try return response. Let me just go ahead in my code here, go to proxy. But I don't know why we started with the CSP. Actually, we could have started with the cannot really go. Yeah, we could have just started the headers, request headers. We could have just started with the normal, with the other headers, security headers. Let's go ahead and do that. Okay, we can check with the security header. Just type security header here. Headers, and we have here security headers, how to import security headers, next headers. Yeah, so these are the headers that we need to be aware about. X-frame option, for example, here. Permission policy, this is basically the header that allow you to control which features and API can be used in your browser. It was previously named feature policy, like this one. So you're telling the application can control the camera, if you want to use the camera, microphone, geolocation. This is the referrer header CSP. So I already have a ready-made here in the I already have a list of headers that we should use. I can just use that one. Yeah, all I have to do is just copy this one, security headers, and yeah, this is it actually. Yeah, I'm just going to put this one here. I'm going to remove this previous to right. It's actually better to use my own. Res means response basically. So since we are using here, so change this one to response. Yes, so that's about it. Change this one to RAS. So you see what I'm doing here? I'm saying here set the X-frame option to deny. Okay, add this header in the response header, and X content pipe put no sniff, and referral policy make it strict origin when cross origin, and strict transport policy use this one, max age for 2 years, include subdomains preload. Okay, and CSP we just added this one. Remember, unsafe eval we have to remove it when we are in production, but in dev we have to add it. And style source here, image source, this is required. Allow API and WebSocket connection, prevent clickjacking, block, prevent base. So this is, I think this is nice. So let me save this one and try it to see if it's working or not. We can just go ahead and run it on now let me go ahead and run my posts here API and see what happens. I'm getting this error again. Let me make sure this is actually running. It's running, but this is not working. Okay, I'm using patch, so let's use get. Yeah, so you can see here headers. You see now it's 13. See, you can go ahead and go down to the headers. You see here we have a header already here set. This is all the CSP headers, okay, that we added, and we have the referral policy here, strict transport, no sniff, and yeah, this is the minimum headers that we need to add in our application. It's important to add it, and there are more we can go ahead and try here. Yeah, we have more secure cookies. Cookies are the most common way to maintain session state. If an attacker can steal a session cookie, they can impersonate the user completely. 3 flags make cookie dramatically harder to steal. Yeah, remember I told you when we make an auth, when we authenticate to a single browser, for example, you're going to receive a cookie, right? Let me show you an example by authenticating to my own authentic application here. I have one application here. Let me try to log into it. Next login. Okay, I'm going to log in. Signed in successfully. Okay, this is my application, by the way. I created it. It's a system for work order management and maintenance management system. So I want to show you now that I signed in. We can actually see the, let me reduce this one. I think it's 100. Yeah, okay, we can go to the cookies here. Okay, see, I'm using better auth for authentication, but look, this is basically the ID, session ID. Okay, like an attacker can actually steal this one using XSS vulnerability or any other vulnerability. Okay, they can manipulate this one or try to access the cookie. Here, you see, this is the cookie. This is what we received from the server when we logged in, when we authenticated. This is secure because you see we have different headers here set to make it secure. First of all, we have HTTP only header. Okay, what this means is basically this prevents access with JavaScript to access from accessing this cookie. This is very important. But this is how we can protect our cookie from XSS kind of attack. Secure means, you see check here, it means that it's transported securely using HTTPS instead of HTTP. Okay, same site is basically make sure that they have different versions of same site. This prevents against CSRF attacks. Okay, we have lax and strict. Okay, CSRF token here. CSRF attack is basically when an attacker uses your browser. Okay, for example, let's say I've logged into a bank here, bank here, any bank, doesn't really matter. Okay, I've logged in. Okay, logged in successfully and everything. So our let's say there is another page here, this evil.com or whatever, any website that is malicious. I am trying the attacker can make this site access your bank.com site and make it transform balance to his account using the browser vulnerability. CSRF, this is what we call CSRF attacks. Let me show you what CSRF attack is. CSRF attack. Let me go to the image here. Yeah. It exploits the 1 second here. This one is nice actually. No, this one. So let's say a victim logs into a bank account. Okay. Using the browser. This is the bank website. Okay. Then the bank assigns a victim a validation token to the victim. And here's what the hacker does. Hacker sends a forget request, okay, disguised as legitimate communication from the bank. Okay. And the forget request is executed by the bank using the previously assigned validation token. Okay. And victim unknowingly forwarded the request to the bank. Okay, see, we used the yeah. So let me show you another example here. CSR. Okay, this is CSRF tokens. No, but we need to know attack. Let's say this is the website visitor. No, this is the perpetrator. It's the attacker. Okay. He forges a request to a fund transfer to a bank. Okay. Perpetrator embeds the request into a hyperlink and sends it to a visitor who may be logged in to the site. Okay. And this is the visitor, and what the visitor will do is clicks on the link and inadvertently sends the request to the website. Okay. So the website validates the request and transfers fund from the visitor account to the perpetrator. All this happened because because of this. This is what we call CSRF attack. Okay, it all happens on the background. This happened only because the website visitor actually has opened his bank account on the web browser or any other account. He has a token received from the server and everything. And so basically, while he's inside his session, he clicks victim's link, and then the issue happens. So this is basically what it means by secure cookies. Okay. So we said that HTTP only when the flag is set. JavaScript running in the browser cannot access cookies via document cookie. This means that even if an XSS attack executes malicious JavaScript on your page, it cannot read the session token. Okay, that's why we should set a secure cookie. XSS can't steal this one. Okay, without HTTP only, it can be stolen, but with XSS it's invisible to SSS. Cookie is invisible to JavaScript. Secure, the cookie is only sent over HTTPS connection. On an HTTP connection, the browser silently drops it. This prevents cookies from being intercepted via man-in-the-middle attack on an encrypted connection. This is the idea. Using HTTPS to transfer the cookies يعني to prevent man-in-the-middle attacks. Same site, just like I told you, protects against cross-site request forgery, CSRF attack. Tricks a logged-in user browser. Remember, this is going to affect the browser here, user's browser, okay, into making unintended authentication request to your API from the malicious third-party site. Okay, so we have three types of same site. We have strict cookie never sends and on cross-site requests. Maximum protection may break OAuth flow. Okay, this is too strict. Cookie never sends any request to the cross-site request. While we have lax here, cookie sends on top-level navigation, clicking links, but not on the embedded requests. Good for default. Okay, none. Cookies sent on all requests. Must be paired to secure. Use only for cross-site embeds. This is not recommended. You should always stick with lax or strict. Mostly lax for most setups. And we've talked about this and how we set this one. Yeah, we've talked about most of this stuff here. Yeah, we've set it already. Most of this stuff is already set. And add a matcher. And we can add it on the API actually. That's possible. Each option maps directly to cookie. You can add it this way. Okay, and basically that's about it. There is one more concept that I want to cover actually, and that's important concept. 1 second. Let me just put. Okay, this is the final concept that we need to cover in security, and that's relevant to us now. Okay, so when we need to be careful on authorization and authentication issues. Okay, so for example, authentication is who's the user, right? Authorization is what the user is allowed to do. Both must be implemented on every API request, not just the front end. Okay, you have to implement this on both on the front end and the back end on the API also. Okay, so authentication verifies the identity of the caller. Common method, we have session cookies. Server keeps the session, and security level is medium. We have API keys, static token, low security, JWT token, signed token with user info, high, OAuth, delegated token using so user logs in. Okay, the server validates the credential, server returns JWT token, client sends token in every request. This is how it works. This is if you are using JWT, a stateless setup, right? Just sends it to use bearer and sends the token with every request, so that server validates the credentials. In backend verification example here, we have here, it's going to get the request header, authorization bearer token, and verify it. We have a built-in function here, verify, JWT verify, verifies it with the secret that we have, and returns the payload. So now the API knows who the user is. Okay, but authorization BOLA happens when users can access objects they don't own. Okay, BOLA is an attack actually. Yeah. So let's say I have an API like this one. API users 1 to 3. This is my user. Okay, let's say I changed the last number to 4. Okay, let's say I find another user's data. Okay, now they can see someone else's data. This is the idea of BOLA. Okay, they can access objects they don't own by just manipulating the identifiers here. That's it. If it's, especially if it's predictable or something like that. So vulnerable code, okay. Let's say now here we have const user await prisma user find unique where id is equals to request params.id. Now this is vulnerable because basically anyone can just, even if they are not, anyone can just go modify the object identifier, and they're going to be access to if they know the identifier, they're going to be able to access any user's data here, okay. But to secure this, what we can do is like this: const auth user authenticate, okay. And this const user await prisma you find first where id equals to request.params.id and id auth user id. Okay, if you know what's the difference between these two, is that here we are checking it by the user's id. You see, we're fetching the data based on the user's id, not only the id, not only the entered id. Now even if I know the identifier of user B, okay, if I can't just type on the URL 124 and access his data because I'm not authorized, because it's going to check the user ID, which is basically, let's say I'm logged in as a specific user, John or something, like it's going to get that, actually fetch based on that, only the data that's related to me, that's it. Okay, objects relates to me. So I cannot access let's say Sam's user. Let's say Sam's another user, I cannot access his user. This is, let's say, for even if I know his identifier, object identifier. Also, it's recommended to just make it difficult to predict. It's recommended to use UUIDs to prevent this kind of attacks. Okay, so basically this is what we should do. Okay, we should always use the ID as well. Better pattern api.me and fetch using token user ID. Yeah, this is the idea. Okay, you should always use the ID or the user ID or something like that too when you are fetching or doing anything in the backend on the API side, to prevent attacks like Ebola. To prevent BFLA, BFLA happens when user access functions that they shouldn't. Okay, example like this one: regular users should not delete users. Let's say we have this permission on our system. Okay, but if we just use like this, okay, we just allowed anyone to delete whatever here, like this one. Okay, this is vulnerable. Secure code is going to be like this one. First, we're going to authenticate, of course. Okay, always first authenticate. Make sure that the user is already signed in, because and then if auth user.role is not equals to admin, this is to check the role. We have to check the role on the backend also. Throw forbidden. Okay, before running the query, check if the user is authenticated and if he has the permission to actually do this, to delete. Right, this is the idea. The best authorization models we have RBAC, role based, like based on admin, editor, users or something. Let's say we have specific permissions. Always validate ownership. This is critical rule. Object.owner ID is equals to authenticated user ID. It's very important. Always validate ownership. So other additional API protections we have here: rate limiting. I told you already, we tried it also. To prevent brute force attacks. And don't forget the input validation. This prevents API. You have to validate the data before actually sending it, on both in the client side and the server side. You can use Zod, which simplifies this process for us. Actually, Zod makes it simple. And always use random IDs. Don't use sequential IDs, because I can just change the ID and access another user's data, right? Use UUID, which is random, it's complicated. and make it like this one, ID. That's why we set at ID at default CUID. It's reduced border discovery. Security headers, don't forget this headers, this is very important. And don't forget to add the logging also, useful for incident response. Secure API pattern best practice, authenticate user, validate input, always validate the input, and then authorize user, then execute business logic, then return sanitized response, just like this one. This is a perfect example. You see, first, before fetching anything, I'm going to authenticate the user, right? Once it's authenticated, I'm going to actually check the data, make sure it's actually same as I'm going to use Zod here, okay, to validate the data, okay. Then authorize it. Let's say here user, let's check first if the user can actually has the permission to read the post. Then I'm going to fetch the data that belongs to this user only, since I'm using author ID equals to user ID, right? This is basically what we need. There are other attacks that I didn't cover here, like for example, we have what do you call it, SQL injection, which is actually not very usually we are secure from SQL injection because we use ORMs, right? ORMs means like Prisma. We don't write raw SQL queries like this one, like we used to before. So basically the issue with SQL injection is like same like XSS, like whenever if you have an input field there, an attacker can write any query here if they know SQL, like they can type like this, or 1 - 1 like this, for example, and they can just put it inside your field. So it will just, you see this comma here, it's going to close your code, and then it's going to say 1 equals to 1. That means 1 is always equals to 1, right? So it's going to display everything, all the user data and everything. So to sanitize it, you should use parameterized queries like this one. So it will even if the user enters commands like this, it will be treated as string, not code. Understand? This is the benefit of parameterized queries. Like you can use like this. You can use $sign here 1. You can put a placeholder. Instead of allowing users to put the code directly to the SQL query here, you can just put a placeholder here, any variable here, and use db query here, statement, user input. Okay, so this is parameterized queries. You can read about it, and this is basically it for authentication. And we've talked about most of it. It's better to use auth providers for authentication. And let me show you something about authentication. In the post here, we can go here. Let me demonstrate to you this attack, Bola attack and stuff. Let me go ahead and log into my application. Remember this application? Yeah, this is my application, right? Okay. Now, let's say I want to run this application from my from here. You think I can do it? Not here. This is not from here. Let me do it from here. Let me type API here, because I have an API with that has this data for me. This is my data. Okay, my work order data. Okay, but if I want to check this from here, do you think it's going to allow me to do it or no? Send. See what I got? 401 unauthorized. Request is unauthenticated. Okay, the only reason I was able to do this is because I'm already authorized, right? You can go to the cookie here. You see, I already have this cookie. But here, but here, from here, I got an error 401 unauthorized. Okay, so this is basically what it means by authentication, and that's basically about it. And yeah, we covered everything, and in the next session we're going to finalize the whole course actually. But here attacker can use, yeah, so always use auth providers like Better Auth or Clerk. Okay, don't try to make authentication by yourselves, because it's much simpler to just delegate this to the auth providers. They know how to do it properly. And attackers can use rainbow table, use composite map, commonly used passwords. Yeah, even if you use hashing, yeah, we talked about this one. Hashing, use bcrypt and arrogance. Yeah, whenever you store, whenever we store passwords to the database, we have to hash the password, right, before storing it. We can use bcrypt or arrogant, but this is not secure because attacker can, if he has access to the database, he can just extract the hashes and breach the database. If they breach the database, they can, if they have good GPU, for example, they can just crack the hash, pre-computed hash. They can use rainbow attack, right? It uses pre-computed hash mapped with commonly used password. It's just going to compare the hash with the commonly used password. It's still not secure. That's why we have to use salting. Salting is just a randomly generated string. Okay, so even if our database gets breached, and it will be safe. And don't use MD5 or SHA-25 for hashing. Modern GPUs are good for computing hashes, can be used for brute force. Yeah, and we call them slow hashing functions, those bcrypt, argon too. Session ID is just random characters, 128 characters. Server creates and stores in our database or Redis. Redis is faster actually, so it's recommended to use Redis. We store some metadata like user info, ID, user agent inside the session ID. Server sends session ID to browser and it's stored inside cookie. Flags HTTP only. If true, prevents JavaScript access to cookie. And remember, don't store in local storage. Okay, it's always better to store in the cookies. Local storage is this one. Okay, you shouldn't store any username or password credentials inside local storage because it can be accessed by JavaScript. Okay, always put in cookie. Secure, we said that. Again, we've talked about all of this. And stateless authentication, we have here header, payload. So the issue with stateless authentication is revocation is hard, and yeah, so I think we've talked about most of the key concepts, and thank you for watching, and see you in the next session.